and welcome back at the FinetLink channel. After we learn about the IPv4 and IPv6 addressing, now we will be focused at the Internet Control Message Protocol. The objective for today is to use various tools to test network connectivity, and we will have to explain how the Internet Control Message Protocol is used to test network connectivity, and by using the ping and traceroute utilities to test network connectivity. We will learn about the different types of Internet Control Message Protocol and the tools that are used to send them. Internet Control Message Protocol is available for both IPv4 and IPv6. Internet Control Message Protocol version 4 is the messaging protocol for IPv4 network, and the Internet Control Message Protocol version 6 provides the same services for the IPv6 but includes additional functionality. We will refer for both protocols as an Internet Control Message Protocol. And the function of those protocols are, the first one is host reachability. As an Internet Control Message Protocol, echo message can be used to test the reachability to a host on an IP network. The local host sends an Internet Control Message Protocol echo request to a host. If the host is available, the destination host responds with an echo reply as it is shown here in the animation. The next is the destination or service unreachable. When a host or a gateway receives a packet that it cannot deliver, it can use an Internet Control Message Protocol destination unreachable message to notify the source that the destination or service is unreachable. This message will include a code that indicates why the packet should not be delivered. Here are listed some of destination unreachable codes for the Internet Control Message Protocol version 4, and here are listed some of the destination reachable codes for Internet Control Message Protocol version 6. And the last one about the Internet Control Message Protocol service is the time exceeded. An Internet Control Message Protocol version 4 time exceeded message is used by a router to indicate that a packet cannot be forwarded because the time to leave field of the packet was decremented to 0. And if a router receives a packet and decrements the time to leave field in the IPv4 packet to 0, it discards the packet and sends a time exceeded message to the source host. And at the Internet Control Message Protocol version 6, also send a time exceeded message if the router cannot forward an IPv6 packet because the packet has expired. Instead of IPv4 time to leave field, in the version 6, they use the IPv6 hop limit field to determine if the packet has expired or not. The time exceeded messages are used by the Traceroute tools, where, as I said, it will check at the IPv4 network time to leave at the packet, and an IPv6, it will check the IPv6 hop limit field. The information and error messages found in Internet Control Message Protocol version 6 are very similar to the control and error messages implemented by an Internet Control Message Protocol version 4. However, at the version 6 there are new features and it is improved functionality that is not found in the version 4. Internet Control Message Protocol version 6 messages are encapsulated in an IPv6 packet. The Internet Control Message Protocol includes 4 new protocols as part of the Neighbor Discovery Protocol, and these are for the version 6. Messaging between an IPv6 router and an IPv6 device include dynamic address allocation that are as follows: router solicitation message and router advertisement message. And messaging between IPv6 devices include duplicate address detection and address resolution as neighbor solicitation message and neighbor advertisement message. And we will see each of them in detail. And the router advertisement message, this message are sent by IPv6 enabled routers every 200 seconds to provide addressing information to IPv6 enabled hosts. The router advertisement message can include addressing information for the host, such as the prefix, prefix length, DNS address, and domain name. A host using stateless address auto configuration will set its default gateway to the linked local address of the router that sends the router advertisement. And here at the figure, you can see that router 1 sends a router advertisement message by saying that hide all IPv6 enabled devices. I am the router 1, and you can use the stateless address auto configuration to create an IPv6 global unicast address. I can give you this prefix. By the way, use my linked local address as your default gateway. And with the router solicitation, an IPv6 enabled router will also send out a router advertisement message in the response to a router solicitation message. And here in the figure, you see that the PC1 sends a router solicitation message to determine how to receive its IPv6 address information dynamically. And you can see the router 1 replies to router solicitation with a router advertisement message by saying that PC1. So at the first is that the PC1 sent a router solicitation message by saying, hi, I just booted up. Is there any IPv6 router on the network? I need to know how to get my IPv6 address information dynamically. And then the second step is that the router 1 replies with a router advertisement message. So it's a replay by saying that the same message that I sent at the router advertisement message. I say that I can give you the information for creating your global unicast address. You can use this prefix and use my local link address as your default gateway. And for the messaging between IPv6 devices, we said that is the network solicitation message. This is when a device is assigned a global IPv6 unicast or linked local unicast address, and it may perform duplicate address detection to ensure that the IPv6 address is unique. To check the uniqueness of the address, the device will send a neighbor solicitation message with its own IPv6 address as the targeted IPv6 address, as it is shown here in this figure. If another device on the network has this address, it will respond with a neighbor advertisement message. This neighbor advertisement message will notify the sending device that the address is in use. If a corresponding network address message is not returned with a certain amount of time, the unicast address is unique and acceptable for use. And as you can see in the figure, the PC1 sends a neighbor solicitation message to check the uniqueness of an IPv6 address by saying that, will whoever has the IPv6 address, let's send me their MAC address. And the last message is neighbor advertisement. This happens when address resolution is used and when a device on the LAN knows IPv6 unicast address of a destination but does not know how is the Ethernet MAC address. To determine the MAC address for the destination, the device will send a neighbor solicitation message to solicit network address. The message will include the known IPv6 address, and this device that has the target IPv6 address will respond with a neighbor advertisement message containing its Ethernet MAC address. And as you can see in the figure, there are two steps. At the first step, routers 1 send an address solicitation network a neighbor solicitation message by saying that whoever has this IPv6 address, let's send me their MAC address. And the PC1 will reply with a neighbor advertisement by saying that I am this IP and my address is this one. To test connectivity to another host on a network, an echo request is sent to the host address using the ping command. If the host at the specified address receives the echo request, it responds with an echo replay. As each echo replay is received, ping provides feedback at the time between when the request was sent and when the replay was received. And this can be a measure of the network performance. Ping has a timeout value for the replay. If a replay is not received with the timeout, ping provides a message indicating that a response was not received. And this may indicate that there is a problem, but could not also indicate that security feature blocking ping message have been enabled on the network. It is common that the first ping to timeout if address resolution needs to be performed before sending an Internet Control Message Protocol to have the echo request. After all the requests are sent, the ping utility provides a summary that includes the success rate on average and round trip time to the destination. And there are types of connectivity tests performed with the ping command as the ping the loopback, and with this it can be used to test the internal configuration of IPv4 or IPv6 on the local host. And to perform this, you just enter the ping command and then the loopback address for both of the network. And a response indicates that the IP is properly installed on the host. This response comes from the network layer, and it is not an indication that the address mask or gateway are properly configured, nor does it indicate anything about the status of the lower layer to the network stack. This simply tests IP down through the network layer of IP, and an error message indicates that the TCP IP is not operational on the host. The second ping is ping the default gateway. You can also ping to test the ability of a host to communicate on the local network. This is generally done by pinging the IP address of the default gateway of the host. A successful ping to the default gateway indicates that the host and the router interface serving as the default gateway are both operational on the network. And for this test, the default gateway address is most often used because the router is normally always operational. If the default gateway address does not respond, a ping can be sent to the IP address of another host on the local network that is known to be operational. If either the default gateway or another host responds, then the local host can successfully communicate over the local network. If the default gateway does not respond but another host does, this could indicate a problem with the router interface serving as the default gateway. One possibility is that the wrong default gateway address has been configured on the host. Another possibility is that the router interface may be fully operational but have security applied to it that prevents it from processing or responding to ping requests. And here you can see that the host pings its default gateway, sending an Internet Control Message Protocol echo request. The default gateway sends an echo replay confirming the connectivity. And another ping command for testing connectivity is ping a remote host. Ping can also be used to test the ability of a local host to communicate across an intra-network. The local host can ping an operational IPv4 host of a remote network, as it is shown here in the figure. If the ping is successful, the operation of a large piece of the internetwork can be verified. A successful ping across the internet internetwork confirms communication on the local network. The operation of the router serving as a default gateway and the operation of all other routers that might be in the path between the local network and the network of the remote host. And in addition, the functionality of the remote has been verified, and if the remote host could not communicate outside of its local network, it would not have responded. And as you can see here, many network administrators remember this, that have a limit or prohibit the entry of Internet Control Message Protocol messages into the corporate network, and therefore there is a lack of ping response that could be due to a security restriction. As we said, ping is used to test connectivity between two hosts but does not provide information about the detail of devices between the hosts. There is a traceroute or the Tracert command that is a utility that generates a list of hops that were successfully reached along the path. This list can provide information, verification, and troubleshooting information. If the data reach the destination, then the trace lists the interface of every router in the path between the hosts. If the data fails at some hop along the way, the address of the last router that responded to the trace can provide an indication of where the problem or security restriction are found. We have the round trip time. By using the Traceroute provides round trip time for each hop along the path and indicates if a hop fails to respond. The round trip time is the time a packet takes to reach the remote host and for the response from the host to return. And there is an asterisk that is used to indicate a lost or unreplied packet. This information can be used to locate a problematic router in the path or may indicate that the router is configured not to reply. If the display shows high response time or data losses from a particular hop, this is an indication that the resources of the router or its connection may be stressed. We have even IPv4 time to leave or IPv6 hop limit. The Traceroute makes sure that to use all the function of time to leave field in the IPv4 and the hop limit field in the IPv6 in layer 3 headers, along with the Internet Control Message Protocol time exceeded message. Here in this animation, we can see how the Traceroute take advantage of time to leave. The first sequence of messages sent from the Traceroute will have a time to leave field value of 1. This causes the time to leave to timeout of the IPv4 packet at the first router. This router then responds with Internet Control Message Protocol time exceeded message, and the Traceroute now has the address of the first hop. The Traceroute then progressively increments the time to leave field 2, 3, 4 for each sequence of message. This provides the trace will the address of each hop as the packet time out further down the path. The time to leave field continue to be increased until the destination is reached, or it is incremented to a predefined maximum. After the final destination is reached, the host responds with either an Internet Control Message Protocol port unreachable message or Internet Control Message Protocol echo reply message instead of Internet Control Message Protocol time exceeded message. And this was all about the Internet Control Message Protocol, where we saw about the Internet Control Message Protocol messages and the ping and the traceroute testing. Thank you for being with us and see you to the next session.